All right, so we're just looking at basic examples of dividing, which basically looks like fractions when you have some exponents. So on this first problem, I'm going to do the same thing I did with multiplying. It's there twice. That's because on the first one, we're going to write it out and kind of understand where the rule comes from. So if I have x to the fifth, that means x times x times x times x times x. I'll go back and put all the little times signs in there. And then x squared on the bottom is just x times x. So when you have things in there and they're all being multiplied top and bottom of a fraction, you can cancel on a one-to-one basis. So that x can cancel that x, and that x can cancel that x. So there's no longer a denominator at all. And in the numerator, I have x times x times x, which is, so I'll just write that x times x times x, which is x cubed. That's my answer. So then if I look at this answer, x cubed, and I look at my numbers, 5 and 2, what kind of a rule are we going to have? Yes. So say it where we can understand it, because I don't... Subtraction. We're just going to subtract the powers. So I'm going to take 5 minus 2 and get 3. And you wouldn't necessarily have to show this when it's all positive numbers, but later when we're adding in the negative exponents, you will want to write this out because we'll have a little keep, change stuff going on and all of those exponent rules. So let's look at just some basic examples over here. So we're just subtracting the power on the top and the power on the bottom. So on this one I'm taking 10 minus 4, and I'll write it out just so it'll be clear in the notes, but you can probably do 10 minus 4 in your head.
5?
Yeah. 6. There we go.
On 3, there's no exponent.
I purposely did that.
Yes,
And 4.
We'll get to that. Okay, so then on number 2, I'm going to look at the A's and the B's separately. So I have 5 minus 4 for the A's, so 5 minus 4. And for the B's, I'm going to have 6 minus 1. So if you have a B here, it cannot be 0 because then it wouldn't be there. You can add in a little 1 there. And so I'm going to get A to the first, B to the fifth, and you could leave that first power off the A if you wanted to. So on these, I think what they were trying to tell me is there's no variables. There's still exponents, they're just on numbers. And so why it's important to know this if you're just looking at numbers is because instead of actually your calculator, when you actually go through that, if you try to put in 3 to the 23rd power, I'm going to guess your calculator, it's going to give you this, which is in scientific notation. It's so big that it's times 10 to the 10th, and you're not going to get all of your digits, and it's just messy. And so you're not exactly sure what that whole number is. And the same thing with 21. But if I know I can just take the 23 minus the 21 in the power, suddenly I have 3 squared, which is just 9. So knowing that can make a problem with those really big exponents a little bit nicer. So on the next one, I'm going to have 7 minus 5, so that gives me 2.
And 5 negative 1.
And then this is 3 and 4, right? So that's going to give me negative 1. So we'll talk about that negative power just a little bit. 4 squared is 16. And then 5 to the negative 1 means 1/5. So what actually happens with that 5 is it becomes a denominator. I'm not going to go into that a lot today, I don't think. That may be there might be a couple. But we'll just attack that when we get there. But basically, if you have a negative power, whatever that is it's going to go to the denominator. But we'll get into that more later. Okay, so moving along. Let's come down to these. I'm trying to let me tilt this. Okay, here we go. So just tell me what the answer to number 1 would be. X to the what?
X to the 2.
7 minus 3 is 2.
It's X to the 4.
It's X to the 4.
Oh, I thought that was a 5.
I thought it was a 5 too.
It's a 3. Alright, so going down to number 2, it's 19 and 11. So 19 minus 11 is 8. So I have y to the 8th. Now, we're going to start seeing some coefficients. which means just regular numbers that do not have power stuck on the front. Those you reduce like a normal fraction. So 6 over 2, I'm going to divide those by 2 and make it 3 over 1. And then I'm going to take the 8 on the m and subtract 1 for the bottom. So 8 minus 1 is 7. So what I'm going to get is 3m to the 7th. And if you really feel like putting all of that over 1, you can, but most of the time they're not going to. When you look at answer keys, that just won't be there. Okay, let's go over and look at number 4. So anybody want to take a stab at number 4? Go for it.
A4, B2.
A to the 4th, B to the 2nd. Very good. Somebody else? What about number 5?
Hang on, let me.
Okay, if you need a second to write, I can pause.
M4,
M4,
M3.
Yeah.
Okay, so m to the 4th, n to the 3rd.
It's actually m to the 4th.
And then on number 6, the 24 and the 6, what's going to happen with that?
Hang on, let me read it.
That's 24 is going to be divided by 6.
So,
4.
so I'm going to get 4 and 1. So basically I'm going to have 4. And then 7 minus 4 makes k to the
Third.
3rd. And what happens if I have 6 minus 6? 0.
And then the T goes all the way.
So that means it just goes away. It's done. Not going to show up. So you might put a note there, don't write t to the 0. Because anything to the 0 power is just 1. I have that on a poster in the back of my room. Any non-zero number to the 0 power is
The
1.
yellow one?
It's the other yellow one. Right above where you were.
The one that's right above it?
No, that's green. The yellow one. There you go. Yellow like your shirt. All right, so let's go to this last box. There is a bit of a twist at the very end. So number 1, 10 minus 3 is just 7. So a to the 7th. Somebody tell me what number 2 would be.
4x to the 5th.
4x to the 5th. Good job. Now number 3 is a little bit tricky. So let me explain what's going to happen here. The 6 and the 9 we can reduce. They both divide by 3. So that's going to become 2/3.
Can't get rid of 6, 9.
You can't get rid of it. It's going to become 2/3. So there will still be
No.
2 and 3 in the fraction. Now,
6, 9.
let's talk about the m's. If there are 4 m's on the top, I'm going to draw this really small. There's 4 m's on the top, and there's 12 on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can't fit them all in there. What's going to happen when I start canceling an m on the top with an m on the bottom?
Could be negative 8.
Yeah, so if you just subtract 4 minus 12, it's negative 8. But you can see what's actually happening. It's going to end up in the denominator. So I just wanted to, I just wrote 8. It should be m to the 8th down here. So you can also get there by just taking the 4 minus 12, and you'd have 2/3 and then m to the negative 8. Anytime you have a negative power, that's going to swing down to the denominator, unless it's already in the denominator and then it jumps. But we'll get into that in a later lesson.